How do we recognize a perfect square? A plus or minus b quantity square is a square plus or minus the double product, 2 times a times b plus b squared. So if you're given something like this and you see that the greatest common factor must be 1, is it possible that this is a square, that's a square? No, these two are not squares, so not a perfect square. But I guess I realized, oh, this is 1 times x squared. It's usually simpler to work with that, and usually I can do it. I'm looking for two numbers whose sum is 12, whose product is 35. Product 35, 5 times 7. 5 plus 7 is 12. The two magic numbers I'm looking for are 5 and 7. And when you factor out, you get the following. But let me tell you something. If this is 1 times x squared and you find your two magic numbers, you don't have to go into splitting up. You have the two magic numbers, 5 and 7, that you can use immediately, skipping these two lines. But be careful, that works only when you have 1 times x squared. So I didn't want you to know about that earlier, because you're going to forget about multiplying a by c. Example 8. Oh, this is a perfect square by itself. This is a perfect square by itself. X, 4. The double product is 2 times 4, so 8x. Oh, too bad this is not plus anyway. That would not have worked. 1 times x squared, 16. 16 is 2 times 8. And 8 minus 2 is 6. So the two magic numbers are 2 and negative 8. Negative 8 because the sum is negative. And the two magic numbers, as I said, negative 8 and 2. Because this is 1 times x squared, you can use these numbers immediately. You don't have to split up the middle term and factor out the greatest common factor. How about this one? 54. 54 is 17 times 3. No, 18 times 3. That's not good. 18 times 3. What about 9 times 6? 9 minus 6 is 3. 9 times 6 is 54. So, plus 9 minus 6. Plus 9 minus 6. How about this one? I recognize this as a square, x squared. I recognize this as 8 squared. Could this be the double product of 2 times 8 times 1? No, it isn't. So that's not a perfect square. What about magic numbers? 64. 16 times 4. And 16 plus 4. Or negative 16 minus 4, negative 20. Both numbers are either positive or negative. Both numbers have to be negative. So I said 16 and 4. Negative 16 and negative 4. Negative 16, negative 4. Is there a greatest common factor? This can only be 3 times 3. 3 goes in here, and in here. You can factor out 3. Can you factor out 9? Yes. 1 plus 8 is 9. 5 and 3 and 4 is 9. You can factor out 9. 9 is the greatest common factor. So after you factor out 9, you're left with x squared plus, no, x to the 4th plus 2x squared minus 15. Think of this as quantity squared, quantity to the first power. You may want to change it to another notation. No, I haven't done it. And 15 is 3 times 5, and 5 minus 3, positive 5 minus 3 is 2. So negative 3, positive 5. But remember, this is x squared squared, this is x squared to the first power. If you let t be x squared, you get t squared plus 2t. You get t minus 3, t plus 5, and t is x squared. Can you factor this further? No, that's not a squared minus b squared. Too bad. A squared plus b squared, generally no. Okay.